Now, what I said in the previous session about Sipser leaving quite a lot between the lines, in this session even more so. And again, I'll give you the overview, but there are even more details that you can prove for yourselves as homework, as brain teasers, if you like. All right. Now, I've written out here. Here's the form of your strings in your language. So O to the P, 1 to the P, O to the P, 1 to the P. Okay, of the form WW. Right. So that we'll refer to this quite a few times. Okay. Now we're trying to show this particular string. I'm trying to choose this particular string to show that it's not pumpable. And to do that, there's a kind of major intermediate step. And the strategy is, now we're using condition 3. And condition 3, if you remember, is Vx, y is got to be less or equal to the pumping length P. Yeah, there. Okay, so the strategy of this proof, the main idea, is to show that this substring Vxy straddles. Now, if you're not a native English speaker, what's straddle? What does that mean? Well, the usual meaning is in the context of horse riding. If you straddle a horse, that means you have one leg on one side and the other leg on the other side. So in this context, to straddle would mean to sort of overlap. And so the strategy of this proof is to show that this substring Vxy overlaps the middle of the string, the string S, right? Now, because if it does not overlap the middle point of your string S, well, that means that all of Vxy is either in the left half of the string or the right half of the string. Okay, makes sense. All right. Well, if this substring Vxy, if it lies totally in the left half of the string, and then, therefore, and here's what I ask you to do for homework, if this lies in the left half of your string S, then pumping it to pumping your string S to this uv squared x y squared z, that has as an effect you get a 1 in the first position of the second half. And that does not fit the pattern of the strings in your language, right? So see, if you look here, there's the halfway mark. Okay. So the first symbol in the second half of an acceptable string has to be 0. Okay. So I'll say it again. So this substring Vxy, it has to overlap or straddle the middle point of the string S. Okay. Because if it doesn't, then this here has to either exist totally in the left half of the string or the right half of the string. Now, if it's in the left half of the string, if you then pump the string this way, so you get a v squared and a y squared here, then, and this is leaving this for you to show, then that pump string will have a 1 here on the leftmost symbol of the right half, and that's not allowed because it has to be a 0, right? because the string has to be of this form. It has to be a 0. So it can't be on the left-hand side. And then similarly, we'll show with similar reasoning that it can't be on totally on this cannot totally be on in the right-hand side of the string S either. And why is that? Similarly, in the second half of S, again pumping the string to this with a v squared y squared, then so you'll get a 0 in the last position of the first half. So the last position here will be a 0 if you pump to this. But that's not allowed, because to be an acceptable string in the language, the last position of the left half has to be a 1. Right? You can see from here it has to be a 1. So that's not allowed either. Okay, so we've excluded the possibility that this could lie totally in the left half. We've excluded the possibility that this substring lies totally in the right half. And that only leaves one possibility, right? That this substring lies over, straddles the center of the middle of the string S. Okay, so because if it doesn't, we get unpumpable strings. So now our attention concentrates on those strings where, well, the division of the string S, where your VXY overlaps the middle of the string S. All right. Then what? Okay. So the substring here does straddle the midpoint, the middle of your string S. So what we're going to do now is we're going to pump down. We're going to pump down. So your string UVXYZ will get pumped down to just UXZ, right? And when you do that, you'll end up, this will take the following form, right? And the P's and P's, that's okay, but the I's and J's, you can, and this is what you're asking you to show as homework, details, right? And this is almost verbatim. I've almost copied word for word from Sipser. So he's, if only I'd bothered to check the qualifications, if you like, the ability level of the writer. And if I realised he was an MIT professor who had lectured for years to MIT students, that would explain a lot, because there's so much between the lines here. He assumes his readers maybe not quite MIT level, but he's assuming his readers are smart enough to fill in between the lines. So let this be an exercise. So you've got this sort of broad proof, but with lots of little proofs inside the proof. You could call them lemmas if you like. So I'm asking you to prove these little lemmas, these little proofs inside the proofs. Prove this. For example, okay, so we've there are two proofs, little proofs here, right? Two lemmas. When you pump that, you get a 1 into the first position of the second half. You get a sort of 1 here, and the second part of it. Where is it? You get a 0 in the last position of the first half. Like you get a 0 here. There are two little proofs for you. So